Alright, first set of notes that we're going to be doing on area is over area of parallelograms and triangles. So just go ahead and follow along in the area notes packet that I provided for you on Friday. We're first just going to look at the formula for area of a parallelogram and triangle, and these are formulas that you should have already learned back in elementary school and maybe gone over a little bit in middle school, and we've looked at them a little bit this year. So we know that for the formula for area of a parallelogram, we know that area is equal to base times height. The base and the height we'll talk about in a second, what they actually represent. The formula for area of a triangle is also going to be base times height, but what we're going to be doing is then dividing that product by 2. Now, a lot of people will say base times height divided by 2. Some people will say 1/2 times base times height. Either one of those is representing the same exact formula. You're either going to be dividing by 2 or multiplying by 1/2. Both of them are going to give you the same result for your area. Now, the base and the height of a parallelogram or a triangle must be perpendicular with one another. We talked about altitudes earlier on in the year, and we discussed that an altitude is created by creating a perpendicular line with the base and expanding that to the vertex. So to kind of practice what this looks like, let's look below here on these 3 figures. We have 2 triangles and a parallelogram, and what I want to do here is label all the bases and heights in the following figures. Now, in number 1, let's go ahead and assume that this is a right triangle here. If this is a right triangle, that means I already have one set of perpendicular lines. So I can say that this can be my base 1, and this could be my height 1. And the values of these lengths would be able to be implemented into my triangle formula, and I can do base times height divided by 2. Now, let's say we turned our paper around here and looked at our triangle in this way. And we wanted to use this as my base. Well, in order to use this as my base and to create the height that corresponds with it, the height has to be created from this base, be perpendicular from this base, and then go to the opposite vertex. So here, this would represent my height number 2. And then if I wanted to look at my third side I've already labeled previously as height number 1 here, but this can also be base number 3. And if this is base number 3, the height or the altitude of this triangle would be, this could be my H3. So every side of a triangle or every side of a parallelogram can be considered a base. The height just needs to be perpendicular with that base. If we have a problem that's like an obtuse triangle here, let's say that this here is my base 1. In order to create a line that is perpendicular with this base, but also connecting to this vertex, the height actually needs to be created outside of my triangle. So what I'm going to do is extend this base a little bit longer. Now, this does not add to the actual base length. So if this was a length of 10 and I added about 3 units here, that does not mean that the base now becomes 13. It stays its exact same value. The only reason I'm extending it is because I want to make sure that I'm actually creating a perpendicular line here with this base. So if this is base 1, this becomes my height 1. So we notice that my base and my height are perpendicular, and my height is actually created outside of my obtuse triangle. These would still be the values that you would use to solve for the area of that triangle. Now, if we look at a parallelogram, it's very similar to a triangle, except instead of going to we're still going to a vertex of the figure. We have 2 choices now. For example, on this parallelogram, let's say that we're using the bottom as my base 1. Now, my height still needs to be perpendicular with this base, and it needs to be drawn to one of these 2 vertices. So this height, let's say I want to create the height here, that this is my height length, and this is my H1. Okay, I could do base times height now in order to get my area. But I could also create my height here, just like I did on an obtuse triangle. And these 2 values are actually going to be the exact same lengths. And one reason we know that is because what we've done, when we've drawn these 2 heights, is created a rectangle where opposite sides are going to be congruent. So your height on your parallelogram can either be drawn on the inside or the outside, just as long as they are perpendicular with those bases. Alright? So that's just a little bit of practice in looking at how to label the bases and the heights and the different bases and the heights that you're going to see. So now let's look at some example problems. Now you're used to just seeing some pretty basic area of triangle and area of parallelogram problems. We're going to be implementing a little bit of what we've learned with geometric mean and trig in solving some of these example problems. So let's look at example problem number 1. Here I have a right triangle, and the hypotenuse of this right triangle has been split up into a length of 6 and 24. And then I have my altitude that's drawn right here. And the question is asking me to find the area of this triangle. So we're going to use geometric mean in order to figure out what the base and the height is. Now remember, I have 3 bases to work with. I can say that this is the base of my triangle, or I can say that this is the base of my triangle, or I can say that this is the base of my triangle. So since I already have these values given, I'll go ahead and say, okay, this is the base, and I know my base value is going to be 30 units in length. So I'm going to go ahead and write that over here as some given information. So I know that my B value is going to be 30, and that comes from the 24 plus 6. Now, if I'm going to use this as my base, that means that my height has to be this line here. Reason being is because my height needs to be perpendicular with my base, and my height needs to connect to the opposite vertex, which this does. So I'm going to go ahead and call this value h to represent height. So my first step in order to solve for the height is to use geometric mean. Remember, geometric mean is not like normal mean, not arithmetic mean where you're adding 2 numbers and dividing by the number of numbers that you have. So I wouldn't do 24 plus 6 divided by 2 and get 15 for h. Geometric mean is a type of proportion. And to set up geometric mean, I'm going to utilize both of these numbers as different parts of my proportion, and h is going to be used twice. We're finding the length of that altitude. So the setup is going to be 6 over h is equal to h over 24. 6 over h is equal to h over 24. So that's solving for the geometric mean, which is the altitude of my right triangle. So the way that this proportion is set up, I can now use my butterfly method or cross multiplication, whatever you want to call it, to solve for h. So I have h times h, which is h squared. Okay, I have 6 times 24, which is 144. So now to solve for my h value, I just want a value that when it's squared will equal 144. So in order to solve for that, I'm going to take the square root of both sides so that h can be dwindled down to just 12. So now I have enough information to implement these into my formula and solve for the area of my triangle. So I know that area is equal to base times height divided by 2. So 30 times 12 divided by 2. My numerator is 360. That's the result of 30 times 12. And that means that my final answer is 180 units squared. So that's the area of that triangle. So we utilize geometric mean to solve for my missing height. Once we found the height, I multiplied my base times height, divided it by 2 to get my area. Alright, let's look at this parallelogram problem that's here. On this parallelogram, I'm looking for area. I have a 24-degree angle here in this right triangle. So it's not that this whole angle is 24, just this piece. I have a side length of the parallelogram that's 40. I have another side that's 62. So for this specific problem, I'm going to use 62 as my base, which means that this is going to act as my height. Remember, we talked about the height of this parallelogram can be found in multiple places. Okay, and as long as it's going, in a case of a parallelogram, as long as it's going to one of the bases and is perpendicular with both, we're going to be in good shape. So that's what we're looking for, is this height. So we have a right triangle here in our image. We have a 24-degree angle and a length of a hypotenuse. I have enough information now to solve for my h value by using a trig function. In order to figure out what trig function I want to use, remember our SOHCAHTOA. I have something in my hypotenuse. I have a 40-inch side in my hypotenuse. So that means that I will be using either sine or cosine. I have nothing opposite from 24, which means that I will be using cosine as my trig function, because I'm trying to solve for my value of h. So I'm going to say the cosine of 24 is equal to h over 40. Remember that if the hypotenuse is used, it's always in the denominator of my fraction. This becomes 40 times cosine of 24. And now I can calculate my h value. Please make sure that your calculator is on degree mode when you do this. My height, when rounded to the nearest hundredth, is 36.54. So now I have my base and my height, and I can solve for my area. So area is equal to base of 62 times height of 36.54 divided by 2. So 62 times 36.54, press enter, divided by 2, gives me an area of 1,132.74 units squared. So you should be able to use a couple different trig functions here. Maybe they give you the angle measurement up here, which would require you to use sine instead of cosine. There's a lot of different setups, but I wanted to at least get you one where you were going to be using trig. Now we're going to look at how to solve for area on a coordinate plane. So what you're going to be given on these questions is going to be asking you to calculate the area of the triangle enclosed by the given equations. And the equations that they've given you are linear equations. Y equals negative x, x equals negative 3, y equals 4. So what we're going to do first is we're going to graph these three linear equations. So y equals negative x means that I have a y-intercept of 0 and I have a slope of negative 1. So I'm going to go ahead and graph that line. My next equation is x equals negative 3. Remember that x equals some numerical value. Those equations are going to create vertical lines, okay, where x is always going to be negative 3. So I'm going to go to negative 3 here. The pencil is kind of thick, so I want to make sure I get right on that line. Okay, and I have x equals negative 3. To go ahead and label these, just because that's what a good teacher would do. And then finally we have y equals 4. So it would be a horizontal line where my y value is equal to 4. Now, what we're looking for is where is the enclosed triangle? Where is the enclosed triangle? Well, the only triangle that has been made is this one that's right here. Okay? And if I were to graph this right, we would have had points here, here, and here. So what I'm going to do is I'm going to illustrate that over here to the side. It's going to be a right triangle that has a side length of 1 and 1. Okay? Because what's happened here and why we're graphing this is that every single one of these grid lines is acting as a unit. So when it actually got created and intersected, it intersected where I have a side length of 1 here, a side length of 1 here, and then I really don't care about my hypotenuse. Because with a right triangle, those are going to be acting as my base of 1 and my height of 1. So to solve for area, all I'm just going to do is 1 times 1 divided by 2. This is going to give me an area of 1/2, and I'd like to express this as a decimal just because it just looks more like an area to me than a fraction. So 0.5 units squared would be the area of that enclosed triangle. So on these problems, you're going to graph whatever information they give you, whatever lines that they give you. You'll plot the three lines, see where the enclosed triangle is. Once you get that triangle, then figure out what the base and the height is going to be. Okay? On these, since we're working with horizontal lines and one diagonal, the horizontal and the vertical lines, when they intersect, that's creating your perpendicular lines. So that's going to allow for you to see your base and your height and just to count vertically and horizontally. You won't have to use distance formula or anything here to figure out what those actual links are. You'll just be able to count 1 unit over, 1 unit over, or whatever it may be. Okay, let's look. This is the very last problem, example number 4. It says to calculate the area of the parallelogram enclosed by the equations. So let's go ahead and graph all three of these lines. So we have a line at y equals -1. So we go down here where my y value is always going to equal -1 and create my horizontal line. Then we have one at y equals 4. So same concept. Going to go all the way up here to y equals 4. Graph my horizontal line. Then I have one at y equals -x plus 3. So that means that I'm going to have a y-intercept at 3 and a slope of -1. So I'm going to go up 3 units. Make a little point at my y-intercept. Go down 1 and over 1 a couple times. And create my line. Alright? And then the other one's going to be at -x minus 2. So same exact slope, just going to be at a different place. We're going to be starting at -2 for my y-intercept. Make sure that I have a slope of -1. And create my line. So what you see here is this parallelogram that's occurred after all this intersection. Okay, this parallelogram that's in the middle. So I need to know what is my base and what is the height of this parallelogram. Okay, so the base, I can just use this side here. Okay, and in order to calculate that, I need to figure out exactly where my points of intersection are. So I have a point that's here, and I have a point that's here, and I can calculate at the top or at the bottom. Okay, my lovely graphing here. Point here and a point here. So I know I have 1, 2, 3, 4, 5 units as my base on the top and on the bottom. So 5 is going to be my base length. And then to calculate my height, I'm just going to calculate the length of this vertical line here. Okay, and that's going to be 1, 2, 3, 4, 5 units as well, vertically. So now I have my base and my height for my parallelogram. So I know that area is equal to base times height. So 5 times 5. So the area is 25 units squared. So it's really important to remember how to graph lines. Make sure you don't mix up that y equals -1. It's going to be a horizontal line when you graph it. Any kind of x equals is going to be vertical lines. So go ahead and fill out the form that's at the bottom of the sophia.org page, and please submit the form so you get credit for watching this video.